Welcome to Summarize Science. Have you ever wondered how we teach an AI, like the one in ChatGPT, to get better at a specific skill like solving math problems? One of the most popular ways is through reinforcement learning, where the AI gets rewards for good answers. But there's a problem. Sometimes the AI tries to make a huge, radical change to its strategy, which can be unstable and actually make it perform worse. The common solution is something called ratio clipping, which is like telling the AI, "Whoa, slow down, don't change your strategy that much all at once." However, this paper argues that clipping is like putting blinders on the AI. It prevents bad updates, but it also throws away potentially good information and creates flat plateaus where the AI completely stops learning. So, these researchers propose a new method called probability smoothing policy optimization, or PSPO. The idea is beautifully simple. Instead of just cutting off or clipping the learning when the AI gets too adventurous, PSPO gently smooths the AI's new strategy by mixing it with its old, trusted one. Think of it like this. Instead of a teacher telling a student, "Your new idea is too weird, just stop," they say, "That's interesting. Let's blend a little of that new idea with the method we already know works." This creates what the paper calls a soft trust region, which guides the AI's learning more gently. You can see the difference on these graphs. The red line, which represents the old clipping method, goes completely flat in certain areas. That's where the AI has hit a wall and learning has stopped. Now look at the green line, representing the new PSPO method. It maintains a steady slope. This shows the AI is always learning and getting feedback, just in a more controlled and stable way. To test their idea, the team took an open-source AI model and fine-tuned it on thousands of math word problems. They compared 3 versions: the standard clipping method, a version with no clipping at all, and their new PSPO method. The results were pretty incredible. On the smaller model, the standard clipping method scored just 17.6% accuracy on the math problems. But the new PSPO method achieved 39.7%, a massive improvement of over 20 percentage points. This trend continued with a larger model, where PSPO again outperformed clipping by over 21%. Beyond just accuracy, the quality of the AI's answers was much better, producing clearer and more logical step-by-step solutions. So let's recap. The standard way to stabilize AI training, called clipping, has a major flaw. It can completely halt the learning process. This paper's new PSPO method fixes this by smoothing or blending the AI's new and old strategies instead. This simple change led to a huge 20% jump in performance on tough math problems and produced higher quality, more coherent answers. What does this mean for the future? This is a simple, compute-neutral change that makes AI training both more stable and more effective, and it could be applied to fine-tune AI for all sorts of complex tasks. It proves that when teaching AI, a gentle guide is often far better than a hard stop. Thanks for watching, and don't forget to subscribe to Summarize Science for more breakdowns like this one.